Hello! Arthur here. In the last video we talked about how we would get to Mars and build a base there. Now we've landed on Mars, we need to figure out how to survive. Let's start with growing food. Unlike here on Earth, the soil on Mars contains many chemicals that are toxic to humans. So we can't just stick some seeds in the ground and grow ourselves fruit and veg. At the start of our mission, plants will be grown in solar-powered hydroponic farms. Fertilisers could be added to the soil and toxic perchlorates removed by being broken down using microorganisms added to the soil. Human faeces could be used as a fertiliser, much like in the movie The Martian. Mars has polar ice caps, much like Earth. Water could be drilled out of the ice and purified of potential contaminants to ensure it's safe to drink. Mars could be warmed by using solar sails to reflect light from the sun and heat up the CO2 ice in the planet's ice caps, which would sublime to carbon dioxide gas and could result in a greenhouse effect, warming the planet. Over many centuries, this could be used to terraform Mars into a more Earth-like planet. An artificial magnetic field could be created, but wouldn't have to be created on Mars, and could instead be created on a Lagrange point, where the gravitational force of Mars and the Sun are equal and cancel each other out. This would deflect solar radiation and winds away from Mars. Plants and microorganisms could take in carbon dioxide and release oxygen, making the atmosphere breathable. Communication between Earth and Mars is another issue. Mars is 3 light minutes away at its closest, and 22 light minutes at its furthest. 70-metre radio telescopes, like those in the Deep Space Network, could be used to send messages between the 2 planets. The Deep Space Network consists of 3 complexes around the globe, located 120 degrees apart in Spain, the US and Australia, and could allow for constant communication between Earth and Mars. A day on Earth is 23 hours and 56 minutes long, and a Mars day is 24 hours and 37 minutes long, 2.9% longer. Martian travellers may account for this by using special watches that are 2.9% slower than Earth, that make seconds slightly longer and thus still allow for 24 hours in a day. A year on Mars is 687 days compared to the 365 here on Earth. If you're currently 20 years old on Earth, you would be, rounded to the nearest whole year, 11 years old on Mars and 84 years old on Mercury. There have been proposed calendar systems to measure the years on Mars, although none is currently in widespread use. If we land on Mars in 2033, the 100th anniversary of the event using Mars years won't be until 2133, and will instead be in 2222, 89 years later. The current retirement age is 65 years, so if Elon Musk is able to build a human colony on Mars by 2050, anyone over the age of 35 now could well be the first person to retire to Mars. Retiring to Mars, or to any other place in space, would be brilliant. Getting to live out your retirement, floating in low gravity, or sitting with hot chocolate watching nebulas sounds awesome. But be prepared, because as awesome as it would be, you wouldn't have as much time to enjoy it. Living on Mars or in space would greatly decrease your expected lifespan, as living in space speeds up the shortening of telomeres, which would result in faster aging. We could fix this by lengthening our telomeres, as I mentioned in my video on Could We Live Forever. If humans lived on Mars for many generations, isolated from humans on Earth, it could result in those humans becoming a different species. If many generations lived on Mars, they may evolve through natural selection to become better adapted to the conditions on Mars. These changes may include developing stronger muscles and bones. Carotene, which gives carrots their orange colour, can protect us from UV radiation, and so our skins may come to contain more carotene and as a result would be orange. Greater radiation levels may also cause mutations to take place more rapidly, and for human evolution to take not millions of years, but hundreds of years. These new creatures would have different immune systems to humans, causing any encounter between the two species to be potentially deadly. These Martian humans would also likely have larger eyes, heads and chests, as well as wider hips. However, Mars is unlikely to become isolated from Earth, as starships will probably carry thousands of people between Earth and the red planet every 26 months to populate the planet, and there eventually will probably be regular travel between the two planets. Before we go, consider this scenario. The first humans land on Mars, and over several decades, cities begin to emerge on the planet's surface. Generations go by, causing the population to grow and grow. Terraforming projects start to take place, allowing people to live on the planet's surface. And over many centuries, the red planet becomes the second blue planet. Humanity goes on to terraform the moons of Jupiter and Saturn and the outer planets, and eventually expands out to other planets in the galaxy. But then, an extinction level event results in life on Earth being wiped out, and all contact between Earth and Mars ceases. Over the next few millennia, the Martian origin falls into myth. Eventually, Martian travellers visit our home planet Earth and find the ruins of our civilization. They look upon our crumbling buildings and monuments and wonder about who their human ancestors were and what these strange structures meant to them. Thanks for watching.